Math 3, Unit 11, Section 3. So today we're talking about evaluating exponential and logarithmic equations with common bases. We've basically already been doing this. It's just going to be written in a different form. And I talked about this a little bit when we were reviewing homework, but the property of equality for exponential functions is that if you get them to have like bases, and the base has to be positive, once the bases are like, you drop the bases and that gives you the answer. So this would make sense if you have 3 to the x equals 3 to the 5th, then x does equal 5. They're in the same spot and both of the bases are the same. Okay, here are the steps for writing exponential equations. So the first thing you want to do is rewrite each side of the equation to have the same base. Next, you drop the bases or cancel them out, and then you solve for x. So on example 1, how could I rewrite 81 so that it has the same base of 3?
3 to the negative 4.
Good. So 81 is 3 to the 4th power. Do we all agree? And you could check that on your phone if you want to. Or not phone, calculator. And then how do I get rid of, or how do I make them so that both of the bases are at the same level?
Negative.
Good. So we get 3 to the x equals 3 to the negative 4th power. We can drop the bases since they're like now and they're in the same spot. And my answer is x equals negative 4. Do we have any questions there? Okay, so example 2, I want you to try on your own. Once you get your answer, check with your partner, and then I'm going to be pulling some sticks for help with example 2. Okay, so it sounds like you guys are done. All right, so the first thing I want the first person to do is tell me what you would do in order to get these to have a common base. Okay, so, oh, he's absent. John. Okay, so 16. How could I make that to have a base of 2? Very good. 2 to the 4th power. Okay, so the next question is, how can I make these at the same level? What do I do in order to put the 2's at the same level? Ira.
You put 2 to the x power equals 2 to the negative 4th power.
Perfect. So anytime we bring them up, we get a negative or a positive depending on how you're moving these. And now that we have like bases, we can cancel out the 2's and x does equal negative 4. Any questions? Okay, example 3. Looking at this, I can't change 2 into an 8, but can I make 8 into a 2?
Yeah.
Okay, so 8, we would change 8 to be what?
2 to the 3rd.
Very good. 2 to the 3rd power. And then I have 2 to the negative, and then it's x plus 3 in parentheses. The 2's now can be canceled out because now they're at the same spot like bases, and now we have an equation to solve. I have negative x plus 3 in parentheses equals 3. What would I do here to solve? You could just divide by negative 1, or we could distribute. Let's go ahead and distribute. If you do it the other way, you'll get the same answer. Negative x minus 3 equals 3. Next step would be to add 3 to both sides. We have negative x equals 6. And then my last step would be to divide by negative 1, and x equals negative 6. Okay, questions? On example 4, do we have a question? No? Okay, on example 4, what would be the base I would use? 2. Now, we talked about this, again, actually, when we were reviewing homework today. This 4 is going to be 2 to the 2nd power. And do you see how I already have an exponent up here? What do we do with powers to powers? Yeah, you multiply. Good. And so that means I'm going to have 2 times x plus 2. Okay, so anytime you change something to an exponent and there's already an exponent there, you multiply both of the exponents together. Okay, equals 2, and then 2 is what exponent?
1.
1. Questions up to this point? Okay, so now that I have the like bases, we can drop the bases or cancel them out. And my equation now is 2 times x plus 2 equals 1. In order to solve, what would be the easiest thing to do? Distribute. We get 2x plus 4 equals 1. Next step would be to, good, subtract 4 to both sides. 2x equals negative 3, and my last step would be to divide by 2. So x equals negative 3 over 2. All right, example 5. I'm going to give you a chance to try this one on your own. Okay, and when you are done, go ahead and show me on your fingers what the answer is. Nope. Yes. 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 Nope. 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 Yes. 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 Yes.
Nope.
Good. The purpose is for you to try it on your own to see if you know how to do it, not for you to get the right answer, but for you to know how to do the problem. So it's not like I'm giving points to those of you that get it right and taking away points to those that get it wrong. We just want to see if we're understanding. Good. 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 Okay, so what would be the like base that we should use?
7.
7. Okay, and so the left side's already done. We have 7 to the 2x. 49, how do we change that to be 7?
7 squared.
And when I bring up the exponent, and there's already an exponent there, what do we do with them?
Put the first exponent first.
Yeah, we're going to multiply them, so we put them in parentheses. Is everybody good there? So now I can drop the bases. We have 2x equals, and I'm going to go ahead and distribute this. 2 times 3x is 6x. 2 times negative 2 is negative 4. In order to solve this, what would I do next? Subtract 6x. This eliminates. I have negative 4x equals negative 4. And then we divide by negative 4 to both sides, and x equals 1. Do we have a question there? Okay, I'm going to pull some sticks here for example 6. My first question is, what will be the base that I use? Cole, what will be the base that I use? 3 is correct. Good. So 9 is going to change to be what? Anybody?
3 to the 3rd power times.
Okay, no. 9 is 3 to what power? 2. To the 2 times 2x equals 27 is going to be what?
3 to the 3rd power.
Times x minus 1. At this point, what would you do now? So this first stick, can you please tell me what you would do now? Jonathan? Times the 3's? Oh, good. Cancel the 3's. Perfect. Okay, next step. What would I do, Andy?
You would make 2 times 2x equal to 3 to x minus 1.
Perfect. So 2 times 2x equals 3 times x minus 1. Next step, what will I do, Anthony? Distribute. Good. So 2 times 2x makes 4x, and then we distribute here 2. 3 times x is, and 3 times negative 3, or sorry, 3 times negative 1 is negative 3. And then we're just solving for x, so I'm going to subtract 3x to both sides, and those eliminate, and we get x equals negative 3 for our answer. Any questions? Okay, last one. Sometimes this is tricky for people, but let's see what you guys know. Okay, so I just like some raising of hands this time. So I have the square root of 27. Could I write that can I write 27 in terms of threes? Okay, so 27 is what? Okay, 3 to the third power. Is everybody good with that? So I'm going to rewrite this for a minute. 3 to the x equals the square root of 3 to the third power. And when we have a square root, the root is actually a what? A 2. So who remembers how to change this to be into exponential form and we get rid of the root? Max.
Isn't it 3 and 3 halves? Or 3 and 3 over 2?
3 to the 3 over 2 is correct. This is how I remember it, okay? Whatever the exponent is, exponents are always high, right? And so that goes in the top part of the fraction because it's up higher. And then square root, this 2, it's almost like it's dividing. Think about roots are kind of dividing. And so whatever the root number is, that's the number that goes in the bottom, in the denominator. Okay, and so now that we have that, my answer is x equals 3 over 2. Do we have questions? Okay, let's go ahead and move on. These equations probably look similar to yesterday's. Some of them are a little bit more complicated, as were last night's. Okay, I'll wait till you guys are quiet. So last night, some of you struggled with some of these, and so the way that we're going to talk about these now is that we can always take these log equations and set them equal to x. Once we do that, we then can write them in exponential form. And so to change this into exponential form, it is what? 7 to the x equals 49. Or 7 to what power equals 49. And then we're going to solve these just like we did previously on the previous questions.
X equals 2.
Very good. So x does equal 2. Now my question for you is, could you have done this one in your head? Yes. Some of you can, some of you can't. If you know the answer and you can do this in your head and you know it's saying 7 to what power is 49 and you know the answer is 2, you do not have to go through this process. I am okay with you just writing the answer. Okay? If you get confused, I would go through this process to make sure I understand it and then drop the bases and get the answer of x equals 2. Do we have any questions? Okay, on example 2, on here, how many of you think you know the answer with doing no work? That's pretty good. Okay, so for those of you that can get the answer without doing work, that's fine. But in our notes, I'd like everyone to write down the process. So, first step, set the equation equal to x. Okay, next we're going to change it into exponential form. So I would like this person that I draw to tell me how to write an exponential form. And Calvin, you were the lucky one. How do I write that in exponential form? Perfect. Okay, can I write 27 with base 3? Yes, what is it? 3 to the third. What do we do if we want to bring it so it's not a fraction? Bring it to the negative exponent. So 3x equals 3 to the negative 3, which means that x equals negative 3. For those of you that thought you knew the answer, did you get it correct?
Yes.
Good. Okay, example 3. This one's slightly more complicated. How many of you think you know the answer to this one? Okay. Okay, what do you think it is? I'm just curious. Okay, what do you think it is? Negative 3 as well? Okay, you guys are thinking correctly, but it's not exactly right. What do you think it is? Yes, you're right. Okay. I'm not telling you. Okay, here we go. So before we do this example, I want you guys to think about this. If I were to have x times x like this, what would it equal?
X to the third.
X to the third. And what you were doing is you were adding the exponents because all of those exponents were 1, and so you added 1 plus 1 plus 1 together, which made x to the third power. Does everybody agree? Okay, so on this problem, it's something similar. we are going to set this equal to x and change it to exponential form. Okay, that's going to be our first step. So when I rewrite this, can someone tell me how to write this in exponential form? 5 to the x equals, very nice, 5 root 5. Perfect. Okay, so now we're going to figure out what this 5 root 5 is with it being combined. Just like here, how x times x times x, I combined it, and it was x to the third. Okay, so this 5 right here is really 5 to what power? 5 to the first. Do you guys agree that this is 5 to the first? Okay, now root 5. That is 5 to the what?
1/2.
1/2. Because this is a 1 exponent if it doesn't have one, and the root is 2. So that's why it's 1/2. Now we add those together. When you add them together, it makes 5 to the what?
1 1/2 power.
1 1/2 power. Now, we do not normally see things as 1 1/2 power, and so we need to change that into an improper fraction.
3 over 2.
3 over 2 is correct. In case you've forgotten how to change a mixed number into an improper fraction, you take the whole number and multiply it to the denominator. So 1 times 2 is 2, and then you add the top, which is 3, and you keep it over the same denominator. And so we end up with 5 to the x equals 5 to the 3 over 2. 1 1/2 is the same as 3 over 2, which means my answer is 3 over 2. Do you have questions for me on example 3? Does that make sense? Okay, so we're going to skip to example 6 for a minute. We're going to go back to 4 and 5, but 6 is just like the one we just did. I want you guys to try it on your own. When you get the answer, you can show it with 2 hands.
Oh, so it's more than 5. Got it.
Well, you'll understand it actually when you get the answer. If anybody needs help, raise your hands and I'll come around. You don't have to say it, you just have to show hands.
Did I say it?
Uh-huh.
I was thinking out loud.
Yes.
I know what I'm doing, kind of. Well, she said that you need 2 hands. So, no.
Good.
Well,
I said it. Do you want to hold it?
4 is.
Put it in your back. Don't touch it again.
Okay.
Okay, do you guys want more time? Okay. Show me. Yes. Later. It's too loud. Okay. I want you guys, I'm going to pull 6 step by step. We're going to work through this together. Okay. So, first thing, if this were your paper right now, what would you do first, Bryce? Very good. Equal to x. Next step. What is the next thing you would do in this equation? Please tell me, Aaron. So we just put equal to x. What would you do next in order to solve this?
You do like 4 to the x power, and then equals like 16 and square root 4.
Perfect. So we would change it to exponential form, and that's exponential form. Okay, what is the next thing you would do in this process here? Albert. Yeah, no, you're fine. What base would you use? Or what base should we end up using? It's 4, good. And so we want to change 16 to be 4 to what power? Good, 4 to the second. And then root 4 is what? Close. It's 4 to what power? Okay, so we're looking at these as 2 separate numbers. 16 is 4 to the second power. Okay? How do I write the square root of 4, but with an exponent? Okay, so this is to the 1 power, and this is a root.
Oh, 1/2.
Very good. There you go. Well, I want you to help me. Okay. Now, what do we do? Next step. Help me out here. Lily, what's my next step at this point? Good. And when you add them together, what do you get? Shh. Good. 2 1/2. But we don't see exponents as 2 1/2. So we have to change that to be improper fraction, which is 5/2. Good. So I have 4 to the x equals 4 to the 5/2. And so x equals 5/2. Okay, do we have questions? All right, let's go back to example 4. Okay, what's my first step? Anybody help me out?
Change it to 8, make it
Equals to x. Very good. Okay, equals x. Next will be exponential form. Good.
5x equals √3 1/25.
Good. Cubed root of 1/25. What base am I going to use on here? Ryan.
5.
5. So 1/25 is really going to be 5 what?
-2.
5 to the -2. Is everyone okay with that? So 25 is 5 to the second, but we don't want it as a fraction, and so it's going to end up being 5 to the -2 power. So when I change that to be exponential form, it's going to be 5 to the what? -2/3. That is my exponent, and then that is my root. So this goes to the top, this goes to the bottom. X equals -2/3. Any questions? Okay, example 5. What will I do first?
Make it equal to x.
Equals x. Next.
Change 16 to equal kava.
X equals 16.
So when I originally looked at this looks complicated to me. I don't get it. But when I rewrite it like this, does it look that bad? What base am I going to use? 2. So I'm going to change 1/2 to be what?
2 to the -1.
To the -1, and since I have an x there, it'll be -1x. And 16 is going to be 2 to the 4th. Good. We can then drop the bases. We get -1x equals 4. Divide by -1 to both sides, and x equals -4. Okay, last one for this section, and then we're 2/3 done. What is natural log
10.
base? E. Whenever we have natural log, it's always base E. So let's change this to exponential form. So when I originally look at this problem, it looks confusing. Okay? Now, when I add in the base and put equal to x, let's write it in exponential form. We get e to the x equals 1/√e. Okay, how could I write root e so it's not a root anymore and it's an exponent?
E to the -1/2.
Very good. So we get e to the x equals e to the -1/2 because this e is the same thing as e to the 1/2. And then to bring it up, it gets the negative. So my answer is just what?
X equals
-1/2. Okay, do we have questions? All right, last page here. So this kind of has a mixture of things. Do you know how like when we had like bases, we could drop the bases and solve? Do you guys see here how these are the same logs on both sides? If you have same logs on both sides, you can drop the logs. Yeah. Okay, so now we can solve. Okay, 3x equals 96. Divide by 3 to both sides, right, Ryan?
X equals 32.
And x does equal 32. Okay, example 2. Are these the same on both sides?
Yes.
We can cancel those out. We have 4 equals 2x. What will I do now? Divide by 2. X equals 2. Do you have any questions? So just like when you had the same bases on both sides, when you had the same logs on both sides, you can cancel out the logs, just like we can cancel out the bases. Okay. So example 3. Go ahead and give that one a try. So on this one, again, we can drop the logs. Okay. So going back to example 3, once you drop these logs, because they are the same, just like we drop the bases, we can drop the logs, we get 3 to the x equals 81. This goes back to the first part of the notes. Okay, can I rewrite 81 so it's base 3?
3 to the 4.
Good, so we end up with 3 to the x equals 3 to the 4th power. We can drop the bases, and we end up getting x equals 4. Do we have any questions on that? Okay, go ahead and
You're ahead of me.
try example 4 on your own. And I believe you can show me. No, you can't.
Are you staying like that?
Why?
So it's 7.
Okay, let's. That maybe is it, and I have the wrong answer here.
So until I have the answer.
No. Okay, so do we have like. Oh, okay. Do we have like logs? Yes? Okay, cancel them out. And this is just an algebra equation. 3x plus 7 equals 4x minus 8. You can move things either way. I'm going to go ahead and subtract 3x. These eliminate. I'm going to add 8 to make those eliminate.
X equals 15.
And I get x equals 15. We're just solving for x. Are we okay there? All right, example 5. Is there a natural log right here on both sides?
Yeah.
So we can cancel them out. 2x plus 3 equals 4. What will I do to solve?
Subtract 3.
Subtract 3.
Divide by 2.
2x equals 1, and we divide by 2 to get 1/2. So we canceled out our natural logs, because whenever you have the same on both sides, you can drop them. And then we just have an algebra equation. 2x plus 3 equals 4, and we're solving for x. Okay, on example 6, what base is this if it doesn't state the base?
10.
10. So all you're doing is now going to rewrite this in exponential form. 10 to what power equals the square root of 100?
So what is that? 10x?
So there's multiple ways of doing this. If you wanted to make this so it's base 10, you would write this as 10 squared, right?
And then x equals 2.
So if you have the square root of 10 squared, when you write that in exponential form, you get 10 to the 2 over 2, which is really 10 to the... So 10 to the x equals 10 to the first, which means x equals 1. And you could have figured that out a less complicated way, but... Okay, last one, example 7. How do I rewrite this? X to the 2/3, writing this in exponential form.
Why would you write it as 2/3?
This is saying the base is x.
So would it be x to x?
Okay, do you see how this is written? Okay, this is telling you the power and not the base.
Oh.
Because normally you have a base to what power? They've just switched this around. They're telling you find the base.
X to the 2/3 equals 25.
Equals 25. So when we write this in exponential form. Now, how do you get rid of a 2/3 power?
Multiply by the reciprocal.
Raise each side to the reciprocal power, which would be 3/2. Because what happens here?
That cancels out.
Those eliminate.
X equals 25 to the 3/2.
25 to the 3/2. But could I simplify that? What does this mean?
25 times 3 divided by 2.
The square root of 25 to the 3rd power. And you could think of it like this. Okay, remember the bottom number is the root, the top number is the power. What's the square root of 25? 5. And what is 5 to the 3rd power?
25.
125. 25 times 5. 5 quarters make 125. Any questions?